Okay, and here are the answers to the Wellington College Mathematics 1 paper from 2008. Okay, the first question is about simplifying algebraic terms. Multiply the brackets carefully, remembering that it's minus 2a. Collect like terms, and the answer is 5a. Part B, multiply the coefficients to get 16. Add the indices on the variable to get a to the power 3, 16a cubed. Question C, I put it into a fraction, so I could simplify it by cancelling, and the answer is 4a squared. Part D, write it out, 2a times 2a times 2a, which gives you 8a cubed. Take away a cubed, and you get 7a cubed. And part E, again, just be careful with the minus sign, and it becomes plus 8 at the end. Collect like terms, and you get 6a plus 10. Question 2 was solve the equations. Just be careful to lay it out nicely, show what you're doing. A is 4.5. Part B, just multiply the brackets first of all, and collect like terms on the right sides. Simplify your fraction at the end. 5/8 is probably easier than 0.625. I would leave it as fraction, but that's fine if you didn't. And then part C, I've got my 2 on this side, so I get 8 over a equals 16. Then multiply both sides by a, which gives you that 16a is 8, and then make it into a fraction and simplify it to a half. Part D, I multiplied both sides by 8 minus a to get rid of this on the bottom here, which gave me 2 equals 8 minus a over 3. I then multiplied both sides by 3 to give me 6 is 8 minus a. Then solve the equation, and a is 2. Another way, you could have made that an equivalent fraction, 2 over 6, and then you go straight to 8 minus a equals 6 by comparing the denominators with the same numerator. In part E, I multiplied by the lowest common multiple of a plus 2 and 8 minus a, cancelled out those brackets there, which gave me 8 brackets 8 minus a is 2 brackets a plus 2. Multiply out, get all things on the right sides, solve the equation, and a is 6. Again, you could have made it an equivalent fraction, 8 over 4 brackets 8 minus a, so then a plus 2 equals 4 brackets 8 minus a. Either way is fine. Okay, question 3, it's about simplifying algebraic fractions. With these, it's important that you have the common denominator before you do anything. So the common denominator here is 8, which gives you 3a over 8. B, do a bit of cross-cancelling if you can, and it's a 4a to the power 5 over 3. With this one, when you divide by a fraction, I made it 8a squared over 1. Flip that upside down, do some cross-cancelling, and you get 1/16. Part D, again, the lowest common denominator of 2a and b is 2ab. So you've got to make both fractions with the denominator of 2ab, which gives you b squared minus 16a squared over 2ab. In the final section, part E, was quite tricky. I took the fraction bit here, I multiplied top and bottom by a, which meant I had 2 plus 8a over 2a plus 8. I then cancelled the 2, because there's a common factor in all of those of 2. I then made this 2 as a fraction of a plus 4, by timesing top and bottom by a plus 4. I was then able to add my fractions, which was 6a plus 8 over a plus 4. Remember, when you need to add fractions, you've got to have the common denominator. Question 4 and 5 require you to know how to multiply 2 brackets. The trick is to remember FOIL, which stands for first, outsides, insides, and last. Part A, quite simple, just multiply them out. Part B, first is a times a is a squared. Outside, a times minus 2 is minus 2a. Inside, 8 times a is 8a. And last is 8 times minus 2, which is minus 16. So you've got to multiply each term in both brackets by each other. Same with this one, by using first, outside, inside, last. You get that and then you can simplify it. With D, write it out as a square. First, outside, inside, last. Simplify. And with part E, you can't use 4 because it won't work when there's more than 2 terms inside the brackets. So what I did, I multiplied everything by A, and I multiplied everything by minus 2, which gave me this, which simplified to a cubed minus 8. Question 5 involves factorising quadratics into brackets, so it's like the reverse of what we've just done. So this one, just take out 2a is the highest common factor and think about what you're left with. In this one, because it's quadratic, it's just a squared. I knew my first terms were a, and then I thought, what would I need here and here in order that when I multiplied out using first, outside, inside, last, I'd get that. It was minus 4 minus 4, so I used a minus 4 squared. Same with this one, I took out the common factor of 2, first of all, and then I thought about what I would need in my brackets so that that would work, the first, outside, inside, last. D was very tricky, but again, you knew it was A, and A is your firsts, and then there's a case of thinking about what you would have to have as a second term in each bracket so that it would work as FOIL. And then E, if you look back at the previous question, where it was a cubed minus 8, now I spotted that 8 is a cube number and 1 is a cube number, so I merely swapped 1 in 1 instead of 2 there and there, which again I checked it and it worked. Question 6, I drew a diagram, not so I could count the lines, so I could see what was going on, and then I saw there were 5 vertical lines and 5 horizontal lines, which meant there were 10 lines in total. Each line was 4 centimetres long, so the total length of all the lines was 40 centimetres. The total number of squares was the number of 1 by 1s, 2 by 2s, 3 by 3s and 4 by 4s. There were 16 1 by 1s, 9 2 by 2s. You'll quickly notice they're square numbers, so it's the sum of square numbers up to 4 squared, which gave me 30 total number of squares. Question 7 was the cricket match. They either scored 4 or 3. There are 3 scores that are not possible, 1, 2 and 5. The lowest score you could get 2 ways was 12, I do believe. You just either get 4 3s or 3 4s. And then these are the ways I found of getting 25. It was 4 plus 7 times 3, or 4 4s and 3 3s. So that was quite an accessible question. Question 8, however, was quite tough. We had a certain number of coins. I said let there be 2n coins, and so which meant that half of them were heads, so there are n number of heads. I said let r be the number that would turn to heads that he turned over in his 5, but there are only 5 that he turned over. So the equation I formed was the number of heads plus the number that would turn to heads is now 2/3 of the total number of coins, which if you multiply by 3 and then collect like terms, you've got n is 3 times the number of coins that turn to heads. Now we know the number of coins that can turn to heads is between 0 and 5 inclusive, because you could turn no heads, you could turn 5 heads. So that means that the number of heads he started off with could be all of these numbers here from 0 to 15, multiples of 3, which means that the number of heads could actually be 3, 6, 9, 12 or 15. So the total number of coins is 2n, so 6, 12, 18, 24 and 30. and I got rid of n is 0, because obviously he's turned 5 coins, so you can't have 0 coins, because then that means you can't turn any. I quickly checked it. If there were 6 coins, 3 of them are heads, and he turned 1 of them into a head, and net 1 of them into a head, that means that there's 4 out of 6 which are now heads. So quite complicated there, but we'll get there in the end. Question 9 was average speed. So I drew a quick diagram here, 20 kilometres an hour there, 30 kilometres back. We don't know the distance yet, so I just called it d. So total distance is 2d. The times are d over 20 and d over 30, which gave you a total of 5d over 60. I should have simplified that to d over 12. I didn't, but you could do that. So average speed is total distance over total time. So it's division, flip your fraction and times, cancel out the d's. So it doesn't matter actually the distance between the 2 places, and average speed is 24 kilometers per hour, which just makes sense because it should be closer to 20 than 30, because he spends more time at a slower speed. The total time we know is 1 hour, because they get an hour lunch break, which is the distance travelling there, time travelling there, time travelling back, plus half an hour. Don't use 30 there. Half an hour actually in the shop. Simplify everything out, and you get that it's 6 kilometres away. And again, you can check that by plugging it back into the numbers. Question 10 was looking at when the hour hand and the minute hand will be exactly the same point. Now, the hour hand, this is the number of degrees from 12 o'clock. It's obviously gone to 1 o'clock, which is a 12th of 360 degrees, plus it goes 30 degrees in 60 minutes, so it goes half a degree every minute. And if n is the number of minutes after 1 o'clock, it's gone half n degrees past 1 o'clock. And ditto the minute hand in an hour goes 360 degrees. So if you divide that by 60, it goes 6 degrees per minute. So 6 times n is the number of degrees that the minute hand has travelled from 12. So they'll be in exactly the same place when the hour hand has travelled the same as the minute hand. So the equation is 30 plus n over 2 is 6n. So solve that equation and you get that, rather unhelpfully, n is 5 and 5/11ths of a minute. So it's 5 minutes and 300 over 11 seconds, which is approximately 5 minutes 27 seconds. So the time, when they're both exactly the same place, would be 1:05:27 p.m. So it's 27 minutes basically after 5 past 1. Question 11 was about sheep. I set up a table here. He adds 100 to start off with, then he takes away 101, and so on. I let this variable equal n, where n is the number of the place in the sequence. So it goes 100 minus 1, 101 minus 2, 102 minus 3. So I saw that there's a pattern there. When n is odd, the number of sheep is 199 plus n over 2. When n is even, it's negative n over 2. So when he adds 300, that's actually the 201st term in our sequence. So it's an odd one, so we do 199 plus 201, 400 over 2, which means there are 200 sheep. Question 12, simple equation set up and solved. So the W is 96, and I've just realised that I've done the wrong number. So if you have 8/3 of W, it would be 32, 240, 256. 256 would be the factors of 256 which is basically the powers of 2, I think. And then on this one, 256 is a power of 2, so it would be 2 to the power of 8, I do believe, but I didn't read the question. It is important to read the question, and that is exactly why. Question 13 is Will and Ben. It doesn't take too much to realise that it's 3 and 4, or 4 and 3, which means the sum of their squares is 25. But the most interesting part of this question is the second part, where you have to work it out without knowing what either of them have. And then this goes back to FOIL again. So if you say w plus b squared, by doing first w squared, outside wb, inside wb, last b squared, and that is 49. So w squared plus 2wb plus b squared is 49. And then I also know that wb is 12, so 2wb is 24. So if I take away my 2wb to cancel out that plus 2wb, I get w squared plus b squared is 25, without ever having to know what w and b are. Question 14 is about square numbers. The least number of weeks where it's square number of days is 7 weeks, 7 times 7. Then for the second part, minutes in a week is 7 days, 24 hours in a day, 60 minutes in an hour. They don't need to work that out, because all you really need to know is the prime factors of them, which are fairly easy to work out from this, and then collect them together. You get 2 to the power 5, 3 squared, 5 and 7. Now for it to be a square number, the indices have to be even, which means I need to multiply it by 2, 5 and 7. I don't need to multiply it by 3, because that's already got an even indice, which means that I times it by 70 to make it a square number. So 70 weeks would be a square number of minutes, which is quite interesting to me. And final question, number 15, was a little bit of a problem to try and solve. I realised that the smallest 7-digit number would have to start with a 1 and a 0. The largest I could add on to that to make it so that that's a 2-digit number was 89, which meant I added on 89 to this and got 188, which meant my largest number would be 188, and then those three numbers would all have a difference of 89. So while I'm having a go at those, why don't you have a look through and mark in any corrections, and if you have time, have another go at a few of those.